an object traveling with a speed of 10 meter per second as kinetic energy 1500 joule. The speed of the object is increased to 40 meter per second. What is the new kinetic energy in that? So with the help of first initial speed and kinetic energy, we can find the mass. So we can say kinetic energy equal half mv square. So when the speed is 10, we can find the value of mass, and the energy is 1500 joule at that time. So the mass equal 30 kilogram. Now we have the mass, we can find the final kinetic or new kinetic energy in that one. So that kinetic energy equal, again we are using half mv square, but this time v is 40. So the mass we have already find, that is 30 times 40 square, and we get our answer for kinetic energy new equal 24,000 joule. So our answer is C. The second question said the engine of car exert a force of 600 Newton is moving the car 1 kilometer and 150 seconds. What is the average useful output power of the engine? So average useful power formula is force time velocity. So we can find F equal V, instead of V we can write S by T, distance over time or displacement over time, and the force is 600 time the distance value is 1000 divide the time is 150, and we can simplify this one and we get the answer, that one is 4 kilowatt, because the unit of power is watt. So 4 kilowatt is our answer. Question number 19 and 20 both are from the Hooke's law. So the first question is the extension force graph for a spring is shown. This is extension, this is force, and the unit of extension is centimeter here. What is the spring constant of the spring? And the spring constant is K, and K equal force over extension. And in this question, basically this is the reciprocal of the gradient, and we can find the force is 6, extension for that 6 is 15, 10 to the negative 2, and we get the answer, that one is correct answer for this one is 40 Newton meter for that, Newton per meter. The unit of that one is 40 Newton per meter for that. So this is our answer. Next question is 20, and this question is a wire is extended by a force. The graph shows how the extension of the wire varies with force applied. This is extension, this is force. They said initially a force W gives an extension D. The force is then increased to 2W and the extension increased to 2D. Which area of the graph represent the work done by the force when the force increases from W to 2W? If we can see the graph, so basically the energy or work or energy, we can say that one is basically area under the graph, or we can say that one is for this 1/2 force time, you can say that the extension. As we are going to find the work, the area from W to 2W, so our you can say that we are going to consider this area, this, or you can say this one, but the value is given to us for this one. And if we can see the work for W is from here to here, that we can say that OMT is the work done for W, and the work done for 2W, we can say that one is from 0 to that one is ORS. So it's mean the work done from W to 2W is the change, and that one is PMRS. PMRS. Or if the this one is not given to us, we can also that PMRQ, but this value is not given to us. Otherwise, we can say this is also our work. This work and this work is same for that one. Question number 12. Very interesting, and somehow for the student this question is complicated. I said transverse waves on a rope has a wavelength of this lambda and the period is t. The graph shows the variation of the displacement of the particle of the rope with the displacement and the direction of the travel of a wave at time t equals 0. A particle x is labeled. Which graph shows the variation of the displacement of the particle x with time t? So at time t equals 0, we can see here, this is labeled here, the position of the particle is x. So at time t equals 0, we can say the displacement is 0. Now we are going to convert this graph from displacement to distance time graph to displacement versus time graph. So we need to think, the first thing we can say that at time t equals 0, the displacement is 0. So it's mean that the graph B and graph we can say D, they are not possible because the displacement is not 0 when the time is 0. So these two answers are wrong. Now we need to think about A and C. Another thing that's important for us for the waves, whenever the wave is going down, the motion of the particle is up. When the wave is going up, the motion of the particle is down. And our main attention is for this point, that is x. So at this x, the wave is going down. So it's mean the displacement should be, you can say that the downward for that one, 0 and downward. So our answer is C. So 0 and motion is down for that one. So the correct answer is C. Next question is about waves. Which statement about all type of transverse? So many students, they are confused about here transverse waves. This is not given to us that these are the electromagnetic. So be careful here. So this is transverse. Water and you can say the light waves are electromagnetic. Water is also transverse waves. So generally we are talking in this question, they all have the same speed? No, that's not. Speed is different for transverse wave. These are not electromagnetic. They all have the vibration that are parallel? No. The vibration of the parallel along the direction of velocity is the longitudinal waves, and the motion of the particle is right angle to the direction of velocity is transverse. So this should be perpendicular. This is wrong. They can all form stationary waves. Yes, if you have water waves, if you have electromagnetic waves, or you can say that they all have the stationary waves. So this answer is possible. Now we are going for the D. They can all travel through vacuum. No, the water waves also. So it's mean that's not possible here. So it's mean our correct answer is C. Next question is stationary waves. And this question, if you can see that this is given to us, the source S emits microwaves with a constant amplitude. The microwaves hit a metal screen P and are reflected. A stationary wave is formed between S and P. This is S, this is P. This is wall here, this is speaker here. Speaker is producing the microwaves, and then the Q is detector, and we are changing the position of this Q between S and P. At some places we are going to get maximum amplitude, and at some places we are going to get the minimum amplitude. Now the question is, when we get the maximum and at which point we get the minimum amplitude. The maximum amplitude we get at antinode point and minimum we get at node point. And in this case, the amplitude when we are going from node to antinode, that increase regularly from node to antinode, and again that decrease regularly from antinode to node. So it's mean our correct answer is B, that increases and decreases regularly in that one. Question number 24 is, the siren of moving police car emits a sound waves with a frequency of 440 Hz. So this is the frequency of source, that one is 440 Hz. Then they said a stationary observer hears sound of frequency 494. This is the frequency of observer. The speed of sound and air is 340 meter per second. So V is given to us, that one is speed of sound in medium and air is 340 meter per second. What is the speed of the police car? Speed of the police car we are going to find. There are two situations in this question. For if you can see your data booklet, second page of your paper, there is one formula, that one is F naught equal means observer frequency equal the source frequency V divide V plus minus Vs. First we need to decide is this one is moving towards or away. There are, if we can see that the observer frequency is greater than the source frequency, so this is clear to me that the source is moving towards observer. So towards observer means that the possibility is this, and toward this. So it's mean that B and D they are not possible, A and C. Now we need to, whenever we are moving towards, we need to use negative sign. When the denominator is smaller, so the factor become bigger, so then we can get the value. So our answer for this one is, we can find the negative sign and we get F naught equal FSV divide V minus Vs, and we have the value 494 equal 440 times 340 speed of sound, 340 again speed of sound, and we can find Vs, and the Vs values comes 37 meter per second towards the observer. So my answer is A. Question 25. The question 25 is, an electromagnetic waves has a wavelength of 138 picometer. This is pico. Pico is 10 to the negative 12. In vacuum, to which region of the electromagnetic spectrum does this waves belong? So this is very important for a student to memorize the wavelength of all electromagnetic waves: radio, micro, infra, visible, ultraviolet, X-ray, and gamma ray. And the radio wave is greater than 10 to the negative 3 meter. Microwave is in the order of 10 to the negative 1 to 10 to the negative 5. Visible is around 10 to the negative 7 meter. And the X-ray is 10 to the negative 10 meter. So we must know the values. Now we are moving towards our value, that is 138 picometer. This is our wavelength, and we can write it as 1.38 10 to the negative 10, because pico is 12, negative 12. So it's mean our answer is 10 to the negative 10. So the spectrum, you can say that that one is X-ray for that. So this belong to X-ray.